Good morning, all of you. So today we'll discuss few numericals on the AC circuit. Already most of the things we have covered it. Few more like if frequency changed, if R changes, C changes, how things will be affected, and some with bulb concept also. Okay? Then in the end we'll go for the transformer. The transformer topic is there only for the mains, not there for advanced. In the end I'll just focus on the transformer. Okay, fine. We'll take this question. AC voltage source, this is like this. So earlier R equal to 1 by omega is telling. So what is the expression for this current I naught? So this I naught, you're going to write it as the peak current. We did only for RMS, no? So can you ask something only for peak current? The formulas are same still. I naught V naught by R square plus XC square. So what is XC? XC should be equal to 1 by omega C what R. In fact, X is equal to R only. So this is R square P naught R by root 2. Now the angular frequency is changed to omega by root 3. So the new current will be, it will be V naught R square. So the new reactance, how much it should be equal to? XC dash you call it. So this is changed to omega by root 3 into C. Root 3 by omega C or root 3 R. So this is V naught R square. So what is XC dash? Should be equal to root 3 R. So V naught by 2R it will become. Then, okay, then what is the ratio of I by I naught? I in terms of I naught is asking, no, will adjust here only. So V naught by R is what? I can write it as now new peak current in the circuit. So V naught by R, you can write it as I naught by root 2. Root 2, sorry, this is V naught by R will be root 2 I naught by 2. I naught by root 2. These are some problems are there which are just based on the basic formulas, the 6 formulas I told you, like this expression for current, VRMS, Ohm's law across all elements, then impedance triangle, voltage triangle, then power triangle, then afterwards power factor, then phase angle of circuit, then expression for impedance. So everything revolves around just these basic formulas. And the basic idea across inductor, capacitor, resistor, how current and voltage will be related. Okay, let's next take the next one. In an LCR circuit at resonance, current in the circuit is 10 root 2 ampere. If now the frequency of the source is changed such that the now current lags by 45 degrees, then applied voltage in the circuit, which of the following is correct? Now, so you go back to series resonance. So current in fact, so this is a lead, no? And this is a lag. This is what happened. So here XL greater than XC. In this region, XC greater than XL. That's what happens here. Now it is at resonance. At resonance, how much of current? The current flowing is 10 root 2 ampere. . Come for this one. If the now frequency of source is changed such that now the current lags by 45 degrees. Say at resonance, we'll do one thing. At resonance, what are the conditions? First, at resonance, XC should be equal to XL, and what all impedance should be equal to R, and what is this current 10 root 2. So what all that maximum current that flows should be equal to VRMS, yeah, VRMS by Z. So this should be VRMS by R. And what is I naught value? This is equal to how much? 10 root 2. This was a given. Now, after increasing, so when I increase frequency, when omega is made greater than omega naught, then XL will become greater than XC. Then what is the phase angle of circuit? Tan phi should be equal to XL minus XC by R. Now the current lags by phase angle. What is the phase angle is given? 45 degrees. So the phase angle is given 45 degrees. So this should be equal to 1 XL minus XC by R. If instead of writing XL minus XC, I'll call this is X, that one. So therefore, what is X equal to R? So let's calculate the current now. The new current will be VRMS by, let me use symbols like this, Z naught. So VRMS by Z. And what is Z is equal to? Total impedance of circuit. XL minus XC, let me call that as R. And XC is equal to R. Substitute that. VRMS R by root 2. So what was earlier? VRMS by R is equal to 10 root 2. So the new current will be 10 ampere. This XL minus XC is what? You should write it equal to X, or you can manage in the calculations here. So this is very important in solving the problem. This is given. So all these such numericals you have to, I think I given assignment from there on I picked up here. Very good questions are there, you see that one. They're the typical questions that are being asked in advance. Okay, let's, what all we can do. Frequency must be increased and current after that change is 10 ampere. Frequency must be decreased. This is ruled out. Frequency should be increased and the current after 10 ampere. So this is one option. Let's see that. Option C, frequency must be decreased and current is same as that of initial one. This also, the given information is insufficient. We'll pick up option 1. Take the next one. The instantaneous current and voltage across an AC circuit are given by, there's a current and there's about the voltage. Find the possible values of the elements and average power dissipated in the circuit. Okay, he has not given any other information. No? Straight away is giving instantaneous current and the voltages. So this is the peak value, no? 2 ampere is the peak current. What is the value? This 2 is I naught and V is this 4 ampere, 4 volt is what? V naught here. So peak values, from peak values, can we bring VRMS and IRMS? It's from that we'll get the impedance Z. And after that, do we know omega? Omega is here 100 pi. And what about this? Is it RC or RL circuit? Find the possible values. Huh?
RC.
So current leads the voltage. Current leads the voltage. Current leads the applied voltage. So therefore it must be an RC circuit. Possible values is telling. Sir, I'll assume RLC. Then little bit further information needed. No? So therefore the circuit must be So we need this VRMS, or the phase angle of this is 30 degrees. The current that is flowing IRMS, the phase angle of is 60 degrees. Please make a practice of slowly showing that phase angle also. But sir, till now we assumed only IA and VRMS. Later on in the numerical we were used to show now, or in the graph we used to show it. So sometimes to trouble you, they may indicate like this. So there's a magnitude. So what is the magnitude? IRMS equal to how much it is? IRMS is equal to 2 by root 2 or root 2 ampere. What about VRMS? 4 by root 2. 2 root 2 volt. This will be ampere. Let this be volt. Now can we calculate the impedance? But what to do? This phase angles has to be taken care. Magnitude of impedance we can calculate from here. And what is the phase angle of circuit? So let's search the phase angle of circuit. So this is the this is the current. So this should be the phase angle. Immediately it's a RC circuit. So L should be taken out. I'm going to remove L. Sir, now you can ask question, sir, why you are removing L? Because we have find the possible values is telling. If I assume L, again XL minus XA, how much XL, how much that will not be possible. Or you may put in exam crystal clearly, only one reactive element, one resistive element is there. Only one reactive element is there. He will mention it. So this has to be taken out. Now let's come for, we know phase angle. So from phase angle, what you can write? Tan phi is equal to XC by R. We know omega, so we'll get value of RC is equal to 1 by omega tan phi. This is one thing. Next, after this, we need one more equation. Then impedance, what is the impedance? VRMS equal to IRMS into Z. And further, what is Z is equal to R square plus XC square. Or individually you calculate tan phi is equal to, we know, so XA and XR will get one relationship. I think calculations will be heavier. So we do one thing, just in terms of XA and XR first will work out. So there's a one equation, equation 2. So we know value of Z from here. So solving 1 and 2 will get XC and XR. After getting XC, then use this formula. Is it okay, the phasor diagram? Then the impedance triangle, how it should be? I think you have to be a little bit careful here. So, so how the impedance triangle in the direction of current, it should be R, no? Okay, the impedance triangle. So it should be R. In the direction of, so next after this, what we get is, here you can write it, IRMS VR. Then IRMS is what? The VC should be like this. I think here not zero phase, 60-degree phase angle it should be shown. So with respect to current, it should be 90 degrees. So here what will happen? XC will come here. Then when you shift this, the impedance will come in this way. And there's a phase angle. It's not always zero phase. Here, the current is having phase angle 60 degree and the applied voltage is 30 degrees. The triangle. So sometimes they may give this phasor diagram like this. From here, you are supposed to work out. What is the power factor of circuit? Suppose if I give Z and phi, is it enough to find out R and XC? Please let me put it here only. So what is R? R should be equal to Z cos phi. Resolves it. And at the same thing, what is XC? Z sin phi. In exams, they just give only Z impedance and the phase angle. From that, we'll get R and XC. And I'll give omega. We can calculate the components. Or from triangle, cos phi is equal to that only. Just I'm asking you to resolve component of Z along R, so along this direction, will give the resistance. Component of impedance along the reactive element will give the reactance. Please do make observation. Everything revolves here only. Most of the numericals. Answer, average power. 3
Root
plus
3.
square root 3. 3 plus square root 3. Huh? Okay, I'll write it here. Okay, yeah, fine. Thank you. Okay, no, so this is the, so sometimes it need not be always the triangle what we used to see earlier. Huh? It can be of this one. Next one. It's a purely sine wave, no? You should have information of the sine wave. This red color is what? The current. Do we know time period of this cycle? 20 milliseconds is the time period. See, this chapter, theoretical ideas are first very important. After that, getting that, you have to work out numericals. See, we know theory, but see, every numerical again, we have to put effort, formulas, everything. So almost your ITJ preparation for advance will be of this kind. And that is what this coaching institutions we are doing it. We are not exploring your intellectual ability. For advance, you have to put effort. So I think if you can realize this, with intellectual ability, what will happen is you can manage some rank. If you want something below 1000, no, you have to put effort. So if you want some 2000, 3000, 4000, with intellectual ability, you can manage. But if you want below 1000, along with intellectual ability, effort has to be. What is effort? Working different numericals. And your parents have sent for this coaching institution so that, because intellectual ability, we can't ensure you that in exam, it will help you, it may not help you. See, I think your parents, they know things better. Your parents know that they know things. I think we were somewhere here. There's a best chapter which will enlighten you. So with intellectual ability in exam, you may get success, you may not get success. But with hard work, what happen? You will get success. That's why your parents and everyone will believe that finally the hard work will really help you a lot. So therefore, just mere thinking ability may not help you in exam. Along with the thinking ability, what happen? You should put effort. Effort means here working different types of numericals. Okay, no time period. Okay, something happened. I could not. Time period is 20 milliseconds. Okay, we got time period. So from that, we'll get omega 2 pi by t, 2 pi by 20, pi by 10 radians per second. Current leads the voltage, or voltage leads the current, lags the voltage, no? graph.
Sir, omega should be 100 pi, sir.
Milliseconds, no, it is 20 milliseconds. 20 into 10 to power of minus 3. 100 pi, yeah. Now look at graph. I think it's clearly visible, no? There's the current one, no? Zero, you can see. So it is having a zero phase. What about the voltage? Voltage is having positive phase. So by this time, I think you're clear. If the same voltage, if I draw it, it will have negative phase. Please try to understand now the phase lead, phase lagger. I think not related. Just some information let me share. Then I'll come to this problem. Suppose say if you have signals like this. So which one is lead lag? So let me take the black color one. So this particular thing is what I'll call V1. Then I'll draw another one. I'll take another one. Let it be off like this. It's a rough, not up to the scale. Which one is leading, which one is lagging, how to mention that. So this is, I'll call V1. V2, and the red color one is V3. So V1 is having some V1 is having zero phase, no? And what about V3? V3 leads V1. And what about V2? V2 lags V1. So how to interpret that one? V3 leads V1 and V2 lags V1. What about V3 and uh, V3 and V2? Any relationship between them? Definitely, what will happen? Uh, which is V3? V3. That color is V3. V3 leads V1. V2 lags V2. So V3 lags V3 leads V2. That lead lag, able to understand now. If they give curve, you just take help of this condition here. If they give phasor diagram, it's okay. So can you show these things in phasor diagram? Yes, it can also be. We can also put in phasor diagram. In the phasor diagram, the representation, V1 is having zero phase. V3 is having positive phase. So it'll come like this. Because this is 0-degree angle, no? And what about V2? V2 will come here. Justified, V2 lags V1, V3 beats V1, and V3 leads V2. If they give sinusoidal curves, this is a method. Phasor diagram, it will be much easier. Above 0, this will be. In exam, can be asked anywhere like this. Okay, come for this. So definitely what I can say now, the current lags the voltage, or voltage leads the current. Current lags the voltage means it should be RL circuit or RC circuit. RLC is telling, so we can't say RL or RC. So only reactance, what we can put it here. So altogether, can we say it's a lag circuit? Current lags the applied voltage. Current lags the applied voltage. So therefore, it's a lag circuit here. This much I can write it here. How to get things here, no? So go back to the basic idea of, we'll write expression for V. V equal to sine omega t, the voltage sine omega t plus initial that phase at t equal 0. What is the value of V? V will be 100. Is it, I think some of you are asking, so this is the current one. Huh? I'll draw it. Huh? Some of you are asking, sir, which is a, this is a current. Huh? Okay, let's write for voltage. So at t equals 0, what is the value of voltage? It should be 100. So it is touching here. This should be the 100. So here 100 is equal to maximum voltage is how much? You look at the graph, 400
Sir,
sine
200, sir. Maximum voltage is 200, sir.
200. Yeah. Current is that one, no? Yeah. So now with this, the phase angle will get is equal to 1 by 2 pi by 6. No, I just now told you, no, like components. So here the voltage is in phase and the current is having phase angle of this one. So here the current lags the applied voltage. So VRMS will come here. Justified. This will be, so from this circuit, what we can draw it here. This will be R. This will be reactance and this will be impedance. So again, so what is R? We know phase angle. Can we calculate the impedance of the circuit? Impedance is what? VRMS by IRMS. We know VM and we know IM also. So impedance, I can write it as VRMS by IRMS or VM by IM. Then if I know impedance, can I bring R? R is what? Z cos phi. And what about reactance? Z sin phi. And after this, what is the average power dissipated? It should be equal to or VRMS, IRMS, cos phi, any of the formulas. From graph also can be asked here. Huh? Be careful. Only reactance we are able to tell. How much value of L and C? Not per, because further some information has to be given. Read the question. So directly let's come further. The is telling the impedance of series RL circuit. What is the impedance of series RL circuit? Z is equal to root of R square plus XL square. Impedance of series RC circuit. R square plus X square. And these impedances are equal. R square plus XL square equal to R square plus XC square. So XL equal to XC. Omega L equal to omega C. Frequency is asking 2 pi f. Objectives. Nothing is there. No need to do any diagrams, nothing. Just the basic formulas. It should be Excel. This is XC. Look at this. Some good question. It's asking the quality factor. What is the basic definition of quality factor? F naught by delta F. Or this is equal to bandwidth, no? Then how to calculate bandwidth? Resonance frequency, yes, no. Where the at resonance, what will happen to current will be maximum. Even the powered average power dissipated also will be maximum. So I know resonance frequency here, that is at 7 kilohertz. So what is F naught? F naught is 7 kilohertz. How to calculate the bandwidth? So what was the procedure we followed to get that cutoff frequencies, upper and lower cutoff frequencies? I should consider only those frequencies where the power is at least half of the maximum. And whenever AC circuits, it's about only the average power only is what we indicate here. No? So 1 watt, almost it's 1 watt. So half of the power. So shall we go for the curve somewhere here? I'll drop like this. Then it will cut at specific points. So what is the bandwidth here? So this part will be the bandwidth here, the horizontal distance it will be. So I can shade. Try to see, no, here. For all these, so that I'll just redraw it. Some yellow color was. Now look at this, this yellow color shaded part, yellow color shaded part, you see this one. The green color vertical dotted lines, it will give us the cutoff frequency. No? So how to get that the BW, the bandwidth, what happened? We are supposed to find out by using this data. So from here to here is what I should measure the difference in frequencies. So if they give even the power also, you manage like this, average power. And I think graph something happened. It's not up to the scale. So maybe it is 5 you take it and 9. So I'll let me assume like this. F naught is 7. Upper cutoff frequency, I'll write it 9. Lower cutoff frequency, let me take it 4. Seven by 5. Exactly 4 only it will come here, no? I think it's a 9.5. 1.4.
Yes, sir, 1.4.
7 by 5 is 1.4, no? Yeah, this value is 1.4. Okay, I'm assuming something. So some graph we should have drawn up to this, not that one exactly. I just assume the values here. So 9, or if you, it will slightly change, 9.5 if you take it. And here this is 3.2 or say 4.2. Some not up to the scale. I'm just assuming things like this. You have to be very careful. That this current, impedance, in resonance, the different types of graphs will be available. From that graph only what we can get so many other things here. And somehow if I give the inductance of the circuit, can we calculate the resistance of circuit? What is the formula? Q equal to omega L by R. Omega naught L by R. Omega naught is what we know, F naught. To trouble you, they'll give self-inductance of the circuit. And from this you can bring the R. What is the resistance of the circuit? Maximum, it's not there for advanced quality factor also. Anyway, but still, just have an awareness that one. Only for main cities. Okay, I think previous class we have discussed, no? If we have three sources of, you look at the zero phase having a phase angle of 30 degrees and this having a phase angle of 120 minus 127 degrees. So this will be V1. RMS value I'm indicating. So this will be 30 degrees, no? So it should be V2 minus 127. So this will be V3. Okay, the source is acted upon by 90. So 37. So what is the method we should follow here? Find the resultant voltage. How to find out the resultant voltage? Vector addition, resolving of vectors. Calculate the resultant and get the peak value. So you should replace everything with a one resultant signal, that one. So here definitely V1x will be V1 plus V2 cos 30 minus V3 sin 37. V1y is equal to V2 sin 30 minus V3, the resultant VRMS. These are VRMS, you have to substitute. Or you do one thing, let's go for peak values, these are. Because we know peak values, and what we'll get is peak value. Then, because calculations will become heavier. So what are V1, V2, V3 I substituted? This is a VRMS. Then you'll get the IRMS. Just get ready for, instead of here R, even if there is some inductor is there, how you manage problem? What about the phase angle of this has to be determined, no? How to get the phase angle? The resultant phase angle will be V1y by V1x. Even if I bring one capacitor here, I think you need not to bother anything here. Capacitance say 2 farad. So still can we work out in the same way? Nothing true with this part of the problem. They're just calculating, and what is the effective signal? You are going to write it like this. V is equal to Vm sine omega t plus theta. Theta is what? The phase of applied voltage. In books we don't have much, because see, nobody will use in AC circuit, no, will this one, but in exams can be asked for, because what we discussed is only for one source. You may give multiple sources. In that case, replace all that with equivalent source, and also that phase has to be taken care, because this will determine the phasor diagram. But phase angle of circuit depends on what? The phase angle of circuit depends on what? Depends on just the reactive elements and this particular thing. So just get aware. So in advanced, they didn't ask till now questions of like this, no possibility of asking. How many are there? We'll see problems. Yeah. Oh, so many are there. We'll finish off all this. Now come for this one. This one only. Yeah. I was telling now if both the bulbs B1 and B2 are identical, so they're going to have same resistance. The resistance of the bulb is going to be same. Call R. Then their brightness will be same. B2 will be brighter than B1. How do we can see? Since they're having same resistance, so can we say anything about the current flowing through them? Current flowing in the branch? Because what is the power dissipated across the bulb? The RMS value of the current. Here I1, I2. And what we can say about I1? I1 should be equal to Vrms by Z1. Z1 is given by R square plus Xc square. What about I2? I2 equal to Vrms by R square plus XL square. What is Xc? Xc should be equal to 1 by omega c. XL equal to omega L. Are they equal? Check it. Omega is 2 pi 500 into value of C's. Let me proceed like this calculation. So omega is how much? 2 pi 50 into C is 500 into 25 into 50,000
20 by
by
pi.
20 by pi. Yeah? Similarly, we'll calculate XL. XL should be equal to omega
I.
L 2 pi 50 into 10 into 10 to the power of minus 3. 5 pi?
I, sir.
Only pi. Definitely, I think X is not equal to XL. 3.4 and this one. So XC greater than XL. XC greater than XL. So therefore, I1 will be less than I2. And what is the brightness of the bulb? Power dissipated in the bulb B1 should be equal to I1 square into R. As I2 greater than I1. So power dissipated in bulb 2 will be greater than bulb 1. As frequency of supply voltage is increased, brightness of bulb B1 will increase and that of B2 will decrease. Can we say anything about this? As the increased frequency, as omega increases, what will happen to XL will increase, XC will further decrease, no? Try to analyze this. If XC decreases, then I1 will increase, I2 will decrease. If I1 increases, then brightness of the bulb 1 has to increase. And what will happen to brightness of the bulb 2 will decrease. Which will have more brightness, that is another thing. It's just asking what will happen to their respective brightnesses. So PB1 will increase, PB2 will decrease. Now something related to bulb. So bulb again, the same thing. What is a power dissipated across the bulb? IRMS square into R. That will be the power dissipated across the bulb. What about the power rating? Again, the same set of formulas. What we did for DC signal, the same set of formulas should be applied for AC signal also. How to calculate the resistance of the bulb? Maximum power dissipated across the bulb they give. and they'll give voltage rating across the bulb. So from that, what is the power dissipation, maximum power dissipated by the bulb, they'll give. And what is the voltage rating, they'll give it. From that, we'll calculate the value of R. What we did for DC, the same thing here, it should be VRMS, not even VM also. Anyway, it's not there in our syllabus. Just have an idea that one. Other than means any Olympiad exam, they may ask you. Read the next one. Series says when the inductor is removed, the current leads the voltage. It will become RC circuit, no? It will be. And the phase angle of circuit is given. I'll make it a little bit small. Let's begin like this. So the initial part of circuit, this is a resistance, capacitance, this is a inductance. (200 volt) is VRMS value, and angular frequency is 300. 100 ohm resistance. This much is there. When the inductor is there, the current leads the voltage by 60 degree. The current is circuit when all the components are present. I'll bring another circuit. Across the same source, 200 volt, and this is 300. Let's get into the problem. It's telling what is the phase angle of circuit? 60 degrees. So tan phi 1 should be equal to XC by R, tan 60 root 3. XC, R is 100. So X equal to 100 root 3. So when you know XC, so it's asking now, so it come for this circuit, what will be the current? So in this case, what is I is equal to? 200 volt by root of R square plus XL minus XC whole square. Do we know XC? If from here you brought it, substitute here. Do we know XL? Omega L. Then you get the required current. So like this in RLC circuit, one element will be removed, one element will be added, some set of questions will come. Better compare two circuit diagrams. Gather the information. I think the set of formulas here, no, nothing big. Now, 800 it will come. So he's asking no. The current inside when all the components are present. This current he has given
2.
800.
Current is 2, sir.
Current is 2 ampere. Sorry. Power will be 800.
Power will be 400, sir. The product is 800.
Product is 800. Asking and the okay, P into I is asking. So this will be only 400. So I think you can save time. How to calculate this average power? I square R. You need not to calculate again the cos, phi, everything. Please do save time in exams. So what is this average power? Should be equal to only I square R. So this will be V into I. Again, calculation of cos phi again will be lengthy, no? So it better I square R. Product of that will be 800 P into I. A very good question. So whenever we give such problems, no, so students what happen, they go for phasor diagram. I think try to look at the way he's asking question here. It's not that, see, I said you should draw a phasor diagram. But in exam, what happens, try to make observation. What information is needed? Is it phasor diagram really necessity of the question? Draw it. If not needed, you can avoid. How they are parallel, no? So for what is the basic condition for parallel? Potential drops must be equal. And he has given drops across the inductors here. Across the capacitor C, inductor L, and resistance R1, then the peak value of us. So first across capacitor. So root 5 VC square plus VR1 square should be equal to VL square plus VR2 square. Is it okay? Shall I write straight away this much only? No need to draw any phasor diagram. We know VC. Inductor, VR1 is across inductor. No need of any phasor diagram. Huh? Okay, some parallel circuits, you be careful the way they ask you question. No, again, similarly, one more. Shall we calculate current in individual branches, I1 and I2? The power dissipated in the resistance is what? The total power delivered. I think there is a difference there. Power generated, power delivered. What is the power generated? Apparent power. Power delivered is power dissipated. You should be very careful about these words. So there's nothing, only the clarity of words is needed. Power delivered means power dissipated. Power generated means it should be the power which is the reactive, or what you can say like the apparent power. Nobody will ask you. I think no book will ask you what is the apparent power, and they should not ask them because it is of no use. It's a wastage of time in measuring that. So power delivered means power dissipated only. So how you just straight away calculate the current I1, I2. I1 is 130 by ERMS XC square plus R1 square. I2 is equal to ERMS XL square plus R2 square. This should be equal to I1 square R1 1514 watt. It will come. Check the answers. Okay, power delivered. So it's nothing but power dissipated.
1514.
Yeah, it should be. Just I think only the terminology. We'll do one thing. This already we are aware. Okay, let me start the transformer. Let's start. Now before that, we'll plot some graphs. Let me show for RLC circuit once all the possible graphs, because any some graphical questions can be asked. I'll try to plot it one. RLC we have to plot it. No? Let's take. Let's show all the parameters. So first, this is the RLC circuit. For I am plotting graph for capacitor, inductor, resistor, and there's a current I, IRMS, and this applied instantaneous voltage, instantaneous current here. So I of t, V of t. So current, let me assume a zero phase. Current will be I need one more. For 1.5 cycle, I'll show it. So that will be easy for us to compare things. So this is the current. I think the definitely the voltage depend upon XL greater than XC or XL less than XC. it will change. So what should be the resistance, the drop across the resistor? The drop across resistor should be in phase. This is VR. And let's come for the inductor. Across inductor, what should be the how the current across the inductor directly come for that one. Current lags the voltage here, no? Current is having zero phase. So therefore the voltage should lead the current. So therefore the curve will come from here. Till now they didn't ask possibility of asking. So they should be the VL. For capacitor, what is the condition? Current leads the voltage. So this should be the VC. So one basic idea. What is one basic idea? Look at this some. Now what should be this time? 0, t by 4, t by 2, 3t by 4, t, 5t by 4, 3t by 2. This will be 7t by 4. If you go for one more quarter cycle, it become 2t. This is about the cycle. So let's compare at t equal to 0, this is a thing. At t equal to t by 4, 1/4 of the cycle. So look at the drop across inductor and capacitor. Will be 0, no? So they will test you questions of these kind in exams, more than an option specially. Across an RLC circuit, so that means an RMS voltage is applied, AC signal is energized, energizing RLC circuit, where the phase of the current is taken to be 0. Phase of the current is taken to be 0. Then they'll ask you that one here. So at t equal t by 4, you see both the drop across capacitor and inductor will be 0. What about the applied voltage? One more, I think last we have forgot that, no? The applied voltage. Please compare graph. So I think in exams, through graph it'll be very easier rather than don't take mathematics and try to conclude anything. It'll be very difficult. So here it all depends upon XL greater than XC or that particular thing. So now if I'm writing XL greater than XC, then what should happen to the current? Current should lag the voltage. So I can proceed like this. Oh, part wise I'll plot it. Some not up to the scale. So this is the applied voltage. So sir, why you are plotting like this only? I am assuming that XL greater than XC. Then current should lag the voltage. So therefore the corresponding graph will be like this here. So they may test you with any of this information based on this. I think through graph only it's better to analyze rather than taking help of that mathematical equations. It'll be very lengthy.